Hi everyone. Our next quadrilateral that we're going to learn about is called a trapezoid, and it's very different from the other four. There's a lot of overlap when you talk about parallelogram, rhombus, square, rectangle, certain ones are the same, certain ones are a little bit different. A trapezoid is a very different shape. Now a trapezoid is a quadrilateral where one pair of sides is parallel, but the other isn't. If the other is, it's a parallelogram. But if one of them is parallel but the other is not, that's what we call a trapezoid. So here's a trapezoid. You have a quadrilateral, four sides. The top and bottom are parallel. You can tell because I put the little arrows on them. And then the left and right side are definitely not parallel. They're not even close. So you can tell this is definitely a trapezoid. One pair of opposite sides is parallel, the other isn't. Now I'm going to go through some vocab with you about specific types of trapezoids. And the first one is called an isosceles trapezoid. Now remember, just like an isosceles triangle, in an isosceles triangle, two sides are the same thing here. So in an isosceles trapezoid, the two sides that are not the bases, what we call the top and bottom, are congruent. Now notice, I said one more thing in here. I said the sides and the base angles are congruent. So there are actually three things congruent here. The two sides are congruent. You can see that, those are marked. But you also have two pairs of congruent angles. This one here is congruent to this one here. Now that's what we usually call the base angles. Base means the bottom of a shape. But I want to make sure you guys know that these two angles are also congruent. Because if I took this trapezoid and flipped it over upside down, it's still the same shape, but now the bottom angles are the top angles. They flipped. So when I say the base angles are congruent, it actually means the two on the bottom and the two on the top. Each one, you have two pairs of congruent angles. Okay, and remember, that's an isosceles trapezoid only. That's when the sides are the same. Okay, our next vocab word is a right trapezoid. And a right trapezoid has to do with right angles. And I said in the description, you have right angles on one side. That's important to notice, because if you had right angles on both sides, then it's a rectangle, and it's not a trapezoid anymore, because you have two pairs of parallel opposite sides. So you can't have right angles on both sides of a trapezoid. That would make it a rectangle, and it would no longer be a trapezoid. But if you look at the picture on the screen right now, this is what we call a right trapezoid. It is a trapezoid. In fact, I should have marked this, but let's add our little parallel arrows here so you know it's a trapezoid. So the top and bottom are parallel. We have right angles on one side over here from your perspective, but then the other side has some sort of angled side. It's not a right angle. That's what we call a right trapezoid. Okay, our next vocab word is mid-segment, and it's actually exactly what it sounds like. Segment means line segment, and mid means middle. So if I take my trapezoid, here's the top and here's the bottom. If I find the exact halfway in between, the point between those, and draw a line segment going through the trapezoid, it's a mid-segment. So it would look like this. The top and bottom are the two parallel sides, AB and BC. That red line PQ is the mid-segment because it's a segment that goes right through the middle. And the way you know it's the middle is because it splits this side exactly in half, and it splits this side exactly in half. So that's what we call a mid-segment. So we have a whole bunch of new vocab. Trapezoid number one is a new word for us. We want to know that that's a quadrilateral where two sides are parallel, the other two are not. Then we have an isosceles trapezoid. This one you're looking at is not isosceles. You can tell because AD looks shorter than BC. You have a right trapezoid, and this one doesn't look like a right trapezoid either because you don't have any right angles in there. And then finally you have mid-segment. All right, so here are our trapezoid theorems. Number one, the non-equal angles of an isosceles trapezoid add up to 180 degrees. So let's say this was an isosceles trapezoid. Let's say I marked those two congruent. Now I know the two angles on the bottom are equal, and I know the two angles on the top are equal. But the two angles that are not equal add up to 180. So like this angle here and this angle here add up to 180. And I said on there, that's because of the consecutive interior angle theorem. If I extend my parallel lines and I have two parallel lines and a transversal, which remember I told you right when we started this module, those theorems are going to be important for quadrilaterals because there's a lot of parallel lines. But yeah, that's what those two angles are. Those are what we called consecutive interior angles from module 12 of book 1, I think it was. And they're not congruent, they're supplementary. They add up to 180. Okay, now our other theorem says if you draw on the midsegment, or if you want to find the length of the midsegment, you can do that by adding up the two bases and dividing by 2. And this is one of the theorems that really makes sense. It's a very common sense theorem. It's saying if I have my midsegment from here to here, and I wanted to figure out how long it is, the length of that red segment is going to be exactly halfway between the length of the shorter base and the longer base. So if I know the lengths, if I just take the length of 1, the length of 2, I add them up and divide by 2, I got the midsegment. All right, so let's turn these two theorems. These are our two trapezoid theorems. This is pretty much all there is for trapezoids. So let's take these two trapezoid theorems and turn them into some examples. All right, so number 1, here's the picture I gave you before when we were talking about midsegment. But this time I'm going to give you some numbers. So let's fill them in. I said AB, which is the top, is 10. PQ, which is the midsegment, is 18. And I asked you to find DC. So if you're not reading the question carefully and labeling the picture like I did, the mistake is people go mid-segment, this one's easy. 10 plus 18 is 28, divided by 2 is 14. They tell me the answer is 14. But the answer is not 14 because I didn't give you the two bases and ask for the midsegment. I gave you one of the bases, the midsegment, and I asked for the bottom. So my answer should be longer than 18, I know that. So the answer is definitely not 14. Now, you might be able to kind of figure this out on your own, but what I want to do is show you like the pure, rigid mathematical way to do it by setting up an equation, just so that if the question gets harder, you'll have that to fall back on. So let's do that. My rule is, if I add up the two bases and divide it by 2, I'll get the midsegment. Now I don't know what one of the bases is, so instead of a question mark, let's call it x. So what I want to do is add up the two bases, that's 10 plus x, and divide it by 2 over 2. Remember, a good way to show dividing is fractions. So I added up my two bases, 10 plus x, I divided it by 2 over 2, and that gives me the length of the midsegment. Well, I already know that, it's 18. So here is my question that I want to solve for x. And x is going to be the answer to the question because x is DC. That's what we're trying to find. So first of all, to solve for this question, I want to cancel out that 2 from the denominator. Over 2 means divided by 2, and you cancel out dividing by multiplying. So I'm going to multiply both sides of the equation by 2. Times 2 on both sides. Now remember, on one side, you're not actually multiplying by 2. You just did that to cancel the 2. And what it leaves you is 10 plus x. Now on the other side, you actually do multiply. 18 times 2 is 36. And then what we'll do is we will multiply, or not multiply, we'll subtract 10 from each side to cancel out that positive 10 there. And we got our answer. 36 minus 10 is 26. So your final answer is 26. X equals 26. X was what I was asking you to find. It was DC. And then remember I said, some of you guys may have been able to kind of think of a shortcut here, like to get from here to here, you added 8. Well, to get from here to here, you're going to add 8 again. It's always going to be the same difference between the shorter base and the midsegment as the midsegment and the longer base. And 18 plus 8 does equal 26. So yeah, maybe you found a shortcut for a question. That's good. I mean, it's good to think about things like that and find shortcuts. But what I showed you, that's like the real way to do it, and that'll always work. That's what you can fall back on if you can't figure it out on your own. Okay, let's do one last question. Mid-segment again, same picture, but this time I made it a little bit harder. Instead of just giving you numbers and asking you to find a piece, I gave you expressions, 3x plus 5, 7x plus 17. But we can still do that. So let's put our numbers in. AB, the top, 3x plus 5. DC, the bottom, 7x plus 17. PQ, the mid-segment, is 41. So I have kind of the same situation here, except it's a little bit more complicated. Now I'm going to set it up the same way. I'm going to take the two bases, I'm going to add them up and divide it by 2. So that would be 3x plus 5 plus 7x plus 17 divided by 2. And remember, when I do that, that's what tells me how I find the mid-segment. So that's going to be what equals 41. So I have a very similar equation to the one I just solved. It's just a little bit more to it. Now, when I go to solve this one, let's combine like terms on that fraction part. I have 3x plus 7x would be 10x. I also have 5 plus 17, which would be 22. Now you have two choices here. Number one, I could do the same thing I did on the last question, and I could multiply both sides of the equation by 2 and just solve the question that way, and it would work just fine. It will work. But the other thing here is, since those are both even numbers, 10x and 22, I could actually just divide by 2. I can say, remember, I'm dividing these by 2, so I could say 10x divided by 2 is 5x, 22 divided by 2 is 11, and then I could solve that way. Both ways will work. But if one of those is not divisible, like if this was 10x plus 21 and you didn't want to deal with decimals or fractions, then the better way to do it, and I'm going to do it this way, same way we did before, let's just multiply both sides by 2 and cancel that out. So what I have right now is 10x plus 22 equals, and then that would be now 82. And I'm kind of squeezing myself in here, trying to squeeze it in around me. I think we can do it. Let's finish solving by subtracting 22 from each side to cancel that out. And I get just 10x equals, let's see, 82 minus 22 would be 60. One more step, squeeze it in here at the bottom. Divide by 10 and x equals 6. So we got x equals 6. Now remember, I've been telling you throughout the year, when you think you're done with a question, pause for a second and go back and look at the question. Because I didn't say solve for x here. I said find AB. And AB is 3x plus 5. So I have one more step to this question. And I'm going to move up here to the top where I have a little bit of free space. I'm going to take the 3x plus 5, and I'm going to substitute my answer I just found, 6, for x. So I get 3 times 6 plus 5. 3 times 6 is 18. 18 plus 5 is 23. So final answer is not 6. X equaled 6, and that's most of the work. That's what you had to do. But the final answer, AB, is 23.